very good morning, class. Today we are going to start with this. This is the lecture number 5 of Haloalkanes and Haloarenes, and in this we are going to complete the chapter. Also, we will learn about the reactions of aromatic compounds and all that. So let's start with this. In this, first we will prepare the haloarenes, and then we will go for the properties of haloarenes. Haloarenes, that means benzene ring having any halosome. Yes. So how we will prepare the haloarenes from benzene, that is halogenation of benzene. And in that first reaction, we can say that when benzene reacts with chlorine in presence of anhydrous AlCl3, it must be anhydrous. Yes, anhydrous AlCl3, it will give you chlorobenzene. Okay, I just want to say this thing. This is the unsaturated compound. So in presence of HNU, we cannot do this reaction. Yes, as we were doing in hydrocarbons, it is not possible. HNU ke presence mein we will not do. Yes, if we do the reaction in presence of dark, this reaction can be done. Yes, so this reaction, when we do the bromination for benzene, bromine in presence of bromine reaction in presence of FeBr3, or it can also be said as or Fe dark. Okay, Fe is the catalyst and dark will be the condition, not lighted nahi hona chahiye. Is it okay? Then it will give you bromobenzene and along with the side product HBr. Okay, for the iodination, we have to use the oxidizing agent. It's strong oxidizing agent we have to use. As it is a reversible process, so when this HI forms, this again like it goes back to give the benzene and iodine reaction back. Okay, substance back. So that's why we have to use the oxidizing agent. When we do this reaction in presence of strong oxidizing agent, it will remove this H iodobenzene, and along with this NO2 and H2O will form. This HNO3 actually oxidizes the HI form into H2O. So that's why it will give you the like this reaction. Okay. Now let's move to next. This is another reaction we can do the same way. This is called chlorination and this is called bromination. So we can use any Lewis acid, this FeCl3 or the anhydrous AlCl3. We can take any Lewis acid. Okay. So this is called Lewis acid. What is the role of Lewis acid? Actually, Lewis acid acts here as a generator of electrophile. Okay, it generates the electrophile. So question can be asked that what is the role of AlCl3 or FeCl3 in the halogenation of benzene reaction? So you have to say that it acts as a generator of electrophile. And how does it work? Let me show you. So this is the mechanism of this reaction. So I'm doing with this bromination. So what will happen? This bromination, first it undergoes the homolytic, it will be a heterolytic cleavage. FeBr3 being a Lewis acid, it will attract the bromine towards itself. Yes, so that's why it will cause the heterolytic cleavage, and this will give you Br plus and FeBr4 minus it will form. So Br4 as an electrophile generated. Yes, Br plus, it is electrophile generated. Now you can ask the question that why electrophile, why not nucleophile can react over here? So let me tell you, this is electrophile. Why not nucleophile can attack on that? Yes, you can answer because benzene ring is a highly electron denser group. So the nucleophile cannot attack on that because it feels repulsion and that it cannot attach to the benzene ring. So that's why electrophilic substitution reaction or electrophilic reactions that is favored by benzene. But ऐसा नहीं है कि nucleophilic देता ही नहीं. It will give you, but some certain condition, some vigorous condition we can say. So we will do afterwards. Okay. So next case, this bromine benzene will undergo that dissociation and it will break in this way. If it goes, it will have negative charge over here and this will have positive charge over here, isn't it? Now what will happen? This bromine plus will attack over there, electrophile will attach on this, and here this H of this carbon only I have shown. Okay, and this it will be positive charge, so carbocation formed over here. Now in the next case, what will happen? This case, in the same way, this bond will break on that side we can show the resonance. Okay, this bond will break on this side, this bond will go, so it can be resonance, but we don't have to work for that. We have to just one equation, one intermediate we want. Okay, so what next case it will be like here, this is Br. Okay, in the next case it will form like here in this picture. It is shown the resonance, like how this bond will break on this side, yes, to overcome the deficiency, then positive charge will come over here. So this shows the positive charge over here. Okay, this is showing the positive charge over here. Now what will happen, this will go on this and it will generate the positive charge over here. So here is the positive charge. Okay, so this is the reaction intermediate. These are the reaction intermediate, and this will be like bond we have to mention. Okay, so out of these three, any one, or like I'm taking one, and on that this FeBr minus, since it is unstable, so it will attack back. So what will happen, this H plus H will be like better leaving group. It will act as H plus and will leave its electron and will go with this Br and to form HBr. Okay, then this FeBr3 will come out as it is. Yes, as a catalyst it will come out. What happened next? Now this H has left its electron, so this electron will transfer over here to overcome this deficiency, isn't it? And it will form the double bond over here. You can see that. In way it is like opposite way it is written. It should not be the exact picture will be. Let me draw the picture again. This one just cancel it, or let me draw this again. Okay, so in this case what happened, this H has gone with the Br to form HBr. This bond is now free, it shifted over here, so it will make a double bond over here, and rest as it is it will be. So this forms a bromobenzene, isn't it, along with the side product HBr and FeBr3. So is it this and this, is it different? They both are same thing, because all the carbon position are same in the benzene ring. So it is also one bromobenzene and this is also one bromobenzene. I hope it is clear, the mechanism, and this mechanism is important. It can be asked in your board exam, as well as the mechanism can be through that which mechanism it goes, or what will be the reaction intermediate, and what are the electrophiles. In that way it can be asked in the MCQ form also. Okay, now by electrophilic substitution reaction. So next we are going to make this. This is mono substituted benzene. Like already the benzene ring is substituted. So now on this, if it is Cl2 plus FeCl3, if it goes, it reacts in the same way. Fe here we will write that dark. Okay, in the same way it will act as like as it has done in the benzene ring. It will same act as, and it will give you the ortho product as well as the para position, because this group will decide that where this electrophile will go. And this CS3 is a what? It is a ortho para directing group. We have done in class 11. Yes, ortho para directing. So in this case, this chlorine will attach only at the ortho and the para, not on meta position. Other position pe react nahi karega. It will not go only at the ortho and para. But if it is benzene, so anywhere you can attach, because all the 6 positions are same. But in this case, mono substituted benzene, all the positions are not same. So you have to be very careful that whatever the group is attached to the benzene ring, whether it is electron releasing or electron withdrawing. If it is electron releasing, it will act as a ortho para directing, and if it is electron withdrawing, it will be meta directing. That means the group will attach to the meta position. Yes. Now the next thing, the same way we can do in presence of FeBr3 also, FBr2, it will come bromine. Yes. Here also Fe is dark, and the first one is ortho and the second one is para. And out of this ortho and para, if I will ask which one will be the major product, because of the stability, para will be the major product. Yes. Now this one is iodine HNO3. Again the same way it will give you, but here is a note that reaction of iodine are reversible in nature. So this reaction requires presence of oxidizing agent to oxidize Hi formed during iodination. Due to high reactivity of fluorine, there is a probability of explosion. So fluoro compounds are not prepared by this method. Got it? Why we have prepared the chlorine, we have prepared the bromine and iodine, but not the fluorine. This is the reason, because of high electronegativity of fluorine, there is a probability of explosion. Okay, and that's why fluorine compounds cannot be, we don't prepare by this method. Okay, so this is the reaction for this. Now next, from benzene diazonium chloride. These are the common reaction and it is very important reactions. So you should know that benzene diazonium chloride, that means benzene and N, here it will be double bond. Sorry, it is not triple bond. Diazonium, that means it is double bond only. Okay, so N2Cl, and then it is, if it reacts with a CuCl HCl, it will give you chlorobenzene. And if it is reacting with a CuBr, it will give you bromobenzene. And these two are called Sandmeyer reaction. The same way it can react with the so got it. If it is CuCl and CuBr के presence में catalyst we are using, it will be called Sandmeyer reaction. But if we are using only copper as a catalyst, it will give you the Gattermann reaction. Okay, Ki के presence में if we do that if we warm, it will give you the iodobenzene, and NaNO2HBF4 के presence में if we are doing at the ice cold temperature, it will give you fluorobenzene. So basically this reaction is called fluorine reaction is called Balz-Schimel reaction. There is no specific name for this iodobenzene preparation. Got it? Okay, so this one is that. And next, if we'll move, properties of haloarenes. As I have already told you, due to high electron density of benzene ring, it prefers electrophilic substitution reaction than the nucleophilic reaction. Okay, so let's start with this aromatic AR-SE reaction. That means aromatic electrophilic substitution reaction. So this is like, we can see that here the reaction benzene is there and H is going to be substituted by the electrophile over here. So what will happen, this electrophile will take the position of H and H will come as like this. So see, if like we say that this H plus has come out. Okay, so this is also called as electropudge. This one is called electropudge. Okay, so this is called electropudge. Now electrophilic substitution reaction is the most frequent reaction type found with the aromatic compound, and reason I have already told you. In the classic case, a hydrogen atom is exchanged for an electrophile. Hydrogen is replaced by any electrophile. Okay. Example of such electrophilic substitution reaction are sulfonation, nitration, halogenation, as well as introduction of alkyl and acyl group also as a side chain through the Friedel-Crafts alkylation, acylation respectively. Got it? So this reaction already we have done in that our previous video. So 1 second. Yes, this one is, if we add the alkyl group on the benzene ring, it will be called Friedel-Crafts alkylation, and if we add the acyl group on the benzene ring, it will be called Friedel-Crafts acylation reaction. And for the Friedel-Crafts reaction, it is said as that it will be given by the monosubstituted benzene which is having electron releasing group. That means the benzene ring which is having electron withdrawing group generally doesn't give the Friedel-Crafts reaction. Got it? And in the Friedel-Crafts reaction, one more thing is there, that it will give you the ortho and para product only. So this is the few things which is like which are the important part of the Friedel-Crafts reaction. Okay. Some of these reactions require the application of Lewis acid as a catalyst, and such as bromination of benzene by bromine. So all this reaction will be done by then in presence of Lewis acid as a catalyst, like AlCl3 we can use, FeBr3 we can use. Okay. So now next is aromatic substitution reaction. Some examples, like here it is HNO3 act as a H2SO4. So here the question can be asked that what is the role of H2SO4? Again the same way, H2SO4 act as a electrophile generator. Okay, so what will happen, this chlorine is ortho, and although chlorine is electron withdrawing group, but it is whenever it is attached with the benzene ring, it shows the plus R effect. That means it is increasing the electron density at ortho and para position. So that mechanism we already know. Yes, so the NO2 group will attach either on the ortho position or on the para position. So both the product will be formed. Now chlorine, if it is reacting another further, if it reacts with the bromine and FeBr3, then bromine will be directed towards the ortho or the para position. So this will give you the product. Yes. Next, if it reacts with the H2SO4, this H2SO4 will give you the SO3H as an electrophile, and this SO3H will attach either on the ortho position or on the para position, will be called sulfonic acid. So if it is chlorine attached, so obviously orthochloro benzene sulfonic acid, and this is parachloro benzene sulfonic acid. Got it? SO3H will attach when this H2SO4 is attached, reacted with this. Now aromatic substitution reaction. As I told you already that electrophilic substitution reaction, it will prefer the electrophilic substitution reaction. Not only that, it will always give you electrophilic. Sometime it also gave the benzene ring, also gave aromatic compound, also gave the nucleophilic substitution reaction, but this occurs at the extreme condition. Very specific condition we have to give. Okay, so nucleophilic aromatic substitution is a reaction in which the aromatic ring is attached by the nucleophile. The nucleophile is going to attach. So obviously we know that there is a lots of repulsion will be there. So in that case we have to put some extreme condition, isn't it? So that is extreme condition of temperature and pressure we have to provide. Then only this reaction will be happen. For example, when an aromatic compound is treated with a strong nucleophile, which is considered as a hydroxide, a leaving group like bromide or chloride, whatever it is there, is displaced. Okay. So this is the reaction, bromine, bromo, nitrobenzene. If nitro group is there, NaOH. So we have given this extreme condition 70 degrees Celsius. If we have added, the bromine will be replaced by OH. And this reaction will be favored if it is having electron withdrawing group. Here it is written. These reactions are subjected only to aromatic compound which contains a powerful electron withdrawing group. Got it? So ये तभी possible होता है. Usually a nitro group, and a leaving group usually a halide. जो living group होना चाहिए, that should be a halide, and the electron withdrawing group होना चाहिए, there should be an electron withdrawing group, usually nitro group, which must be ortho or para to the electron withdrawing group. Or ये this halide must be at the ortho and the para position. These are the condition. So important condition are there. Let me make the star over here. Yes. So this is important point that if it is giving the SN reaction, nucleophilic substitution reaction in the benzene ring, there must be a electron withdrawing group, and the leaving group must be halide, जो easily दे देगा, and the halide group should be at the ortho or the para position of the electron withdrawing group. Okay, reaction with the meta position of the substitution is not observed. In general, अगर हमने देखा experimentally, ये not observed है. Such substituents are stabilized by an intermediate anion by resonance. वो जो intermediate anion बनता है, that is by the resonance it is stabilized and it gives the product. Got it? So this is the important point to learn. Now aromatic SN reaction, some note is there. Electron withdrawing group present at ortho and para position to the leaving group enhance the reactivity towards aromatic nucleophilic substitution reaction as it stabilizes reaction intermediate. I have already told you. So जितने ज़्यादा electron withdrawing group होंगे, उतना faster वो reaction होगा, उतना ज़्यादा easily वो SN reaction देगा. So that is the example of this 2,4,6 trichlorobenzene, and this will be 2,4,6 trinitrophenol. What is the name for this reaction? Name for this compound. There is another name, and this is called picric acid. Got it? Okay, some examples of nucleophilic substitution reaction, that is the Dawes process, and very well known process. You have done it, yes. So when this chlorobenzene is subjected to very high temperature and high pressure in presence of a strong base, then it gives first sodium phenoxide, which is on further hydrolysis in presence of an acid, it gives phenol. Yes, this is hydrolysis, we say. Got it? So this is a Dawes process. Next is replacement by NH2 group when this ammonia in presence of Cu2O, there's a high catalyst used, Cu2O के presence में when it reacts, then only this Cl will be replaced by NH2 group, and here the product will be CuCl2 and H2O. Okay, this reaction is like a reaction is there but not commonly used. Okay, ये commonly used नहीं होता है reaction. Replacement by CN group, chlorine is there and cyanide is there. Cyanide is a better living, like a good nucleophile. So what will happen? This will replace the Cl and it will give you cyanobenzene or COCl. Yes. Now nucleophilic substitution reaction via benzyne mechanism. This is not in your NCERT, but it is important. You should know what is the benzyne mechanism. Okay. Necessary condition for this are compound must have at least one replaceable hydrogen atom with respect to leaving group. Attaching base should be stronger in nature. These are the point. ध्यान रखो. At least one replaceable hydrogen atom होना चाहिए living group के respect में. Okay, and मतलब like at the nearest position. Okay, attaching base जो है that should be stronger in nature, and this reaction will be known as elimination addition reaction. मतलब यहाँ substitution तो हो रहा है, but it is known as elimination and addition reaction. That means first, if we know that elimination reaction, whenever any compound undergoes elimination reaction, it forms a multiple bond over here. If single bond is there, it will form double bond. If double bond is there, it will form triple bond, isn't it? So पहले वो elimination reaction यानी कि पहले वो multiple bond बनाएगा, एक extra bond बनाएगा वहाँ पे, and then it will give you the addition reaction. Got it? So this is the important point. याद रखना है. Let's see the mechanism how it is. This is the leaving group. Lg is the leaving group, and the nucleophile is going to attach in the strong base, basic nature. It is yes. So Be, that means it shows the base, and nucleophile is going to attach. So what will happen? This H being better leaving group, ये H अपने छोड़ यहाँ से छोड़ के it will come with this. इसके साथ attach हो जाएगा. Got it? H will attach with the nucleophile, and now this bond is free, so this bond will shift over here. As this bond will shift over here, the leaving group will leave its position. वो अपने इस position यहाँ से bond यहाँ से निकल जाएगा, and it will come out like this. Clear? Leaving group will come. So what will happen? Now this will here it will form the triple bond, isn't it? So now in this case, the अब जब elimination product हो गया, this forms a benzyne. Benzene having a triple bond, isn't it? So this is called benzyne, and or also known as arine. So now on this, ये जो nucleophile which is attached with the hydrogen, that will attach. So what will happen? This will like यहाँ जो this Bu will attach. एक point आपको बता दूँ, that nucleophile will attach to the opposite direction of the leaving group. It will not attach to the place where the leaving group was. Got it? So that means this nucleophile won't be attacked here only. जहाँ leaving group था वहीं attach नहीं करेगा. It will attach on the back side, on the other side. Yes. So this nucleophile will attach over here, and this hydrogen will go back to this position. So this will form like this. Got it? So you can see that leaving group has gone, but the nucleophile is attached, but nucleophile is not attached at the same position where the leaving group was, isn't it? So that is the benzyne mechanism, and it is also called elimination addition reaction. Why it is so known as so? Because first it gives the eliminated product, and then it goes addition product. Yes, it undergo addition reaction to give the addition product. Here a few important, very important points about this benzyne mechanism. When an electron withdrawing group is present, अगर किसी भी compound में electron withdrawing group is present, the intermediate where the negative charge is closest to the electron withdrawing group will be favored. Got it? What I'm saying? That means, like, if this bond is going to break, yes, if this bond breaks, so it will give you the two position. यहाँ पे भी break हो सकता है और यहाँ पे भी break हो सकता है, isn't it? So it says that negative charge closest to the electron withdrawing group will be favored. That means if it goes negative charge giving here, it will be away from this, so this will not be the favored product. But यहाँ पे अगर minus charge आएगा, तो this will be a favored product. So that's why when the nucleophile NH2, like nucleophile I have here in the reaction, it is a NH2 or NH2 ऐसे नहीं लिखा जाता है. This is NaNH2 we write. Yes. So this NH2 as a nucleophile, this will, what will happen? This will attach. So if this bond breaks on this side, so it will have minus charge. That means electron density will be less over here. So nucleophile will attach on this position. So this will result in this group. Yes, NH2 will attach here, negative charge will be here. But if this bond breaks on this side, it will have positive charge, and here the nucleophile will attach. So out of these two, negative charge is in closer to electron withdrawing group in this picture only. So that's why this is the favored product, and this one is disfavored, or we can say that the minor product will be formed. Yes. Now, case 2, if the triple bond between ortho and metacarbon is there. Triple bond is present between ortho and metacarbon. So here also the bond can be break on both sides. It can break on this side as well as it can break on this side, isn't it? So if it breaks on this side, that means meta position पे negative charge. It is away from the electron withdrawing group, isn't it? So if it is away, that it will be disfavored, and if it is closer, it will be favored. So if this bond breaks on this side, that means here it will be electron density less, and that nucleophile will attach on this position. So this will form, isn't it? So ortho पे negative will be favored in the benzyne mechanism, while मेटा पे नेगेटिव विल बी डिसफेवर्ड, और सिमिलरली मेटा एंड पैरा पे जो नेगेटिव चार्ज होगा विल बी डिसफेवर्ड, ऑर्थो एंड मेटा पे दैट विल बी फेवर्ड. क्लियर? In this case, it is like we are comparing meta and para, then meta will be favored. We are comparing ortho and meta, then ortho will be favored. Yes? There is an example that is substituted benzyne. That means already the benzene ring is substituted. Then what happens? Can produce multiple products. For this type of reaction mechanism, what we have to consider that it must have hydrogen at ortho and para position. Got it? So that is the important thing. If it will not be there, ortho position, if it is not there, this reaction won't be possible. Okay, so what will happen in this case? This H will leave this, okay, due to which it will go with this along with this to form ammonium ion, and this bond will free over here, so it will form the triple bond over here. So this is forming benzyne. Now that nucleophile can attack at the A position as well as B position. दोनों ही position पे बनाएगा, and in this case it will be like both product will be in equal proportion. If it is like electron donating group, if it is withdrawing group, then I have explained you that which one will be favored and disfavored. But if in this case methyl group is there or any electron donating group is there, then the reaction, the nucleophile can attack at both the position, either A or B, and it will give you the equal proportion. But in this case, para will never be formed. Just what you have to keep in your mind, that para will never formed. So you can write over here that para product won't be formed. Got it? So this is the important thing that you have to know. Okay, now move to polyhalosine compound, and that is of your last part of your NCERT. This chapter, you can say, and it is not that much important, but few compounds are there which we regularly use. So for that you are supposed to go through with this. So for first polyhalosine compound is methylene chloride. Methylene chloride, that means it will be more than 2 chlorine will be there. That means if you are writing that CH2 group, more than 1 halogen will be there, sorry. So this one is called methylene, okay, and Cl2. So that's why it is, the common name for this compound is called methylene chloride. Got it? Or in the IUPAC name you can say dichloromethane. Dichloromethane, also known as methylene chloride, is one of the polyhalosine compound present in form of solvent, used as a solvent. Okay, it is popularly known for its use in many purposes, such as paint remover, as a process process solvent during drug manufacturing processes, manufacturing process, as a propellant also in the aerosol, and as a cleaning solvent, as a finishing solvent also. So these are the uses for the methylene chloride. Okay, this is the formula: methylene chloride, CH2, Cl2. Now next is chloroform, which is very much important. Like you all are very much aware about this chloroform. The IUPAC name will be trichloromethane, and trichloromethane, also known as chloroform, it is a colorless polyhalosine compound present in the liquid form. It has the characteristics of sweet smell. The boiling point of chloroform is 334 Kelvin. No need to learn all this thing, the formula, and the important thing I'm going to tell you that you have to learn. However, chloroform can slowly oxidize by air and form a poisonous gas, phosgene. So that's why chloroform should always be filled in the bottle up to the brim. Okay, and it should not be kept in the presence of light. So that is the important thing. Therefore, it is necessary to store chloroform bottles away from the sunlight, and it should be completely filled to the brim in order to keep the air out of the bubble. Okay, out of the bottle. Sorry, phosgene is the common name of chemical that is carbonyl chloride, COCl2, and this is the phosgene gas. This is the poisonous gas. However, the addition of little ethanol to chloroform can convert toxic phosgene to a non-toxic compound known as ethyl carbonate. If this is formed, chloroform is formed, agar suppose that a few drops, a few milliliter of chloroform is used up from the bottle, and it is not we forgot to fill the up to this brim, then what to do? It will form phosgene gas. That means the complete solution is now for waste, isn't it? So this can be converted into the non-toxic substance by adding ethyl carbonate. Got it? Okay, so next thing, laboratory uses of chloroform. What are the laboratory use of chloroform that we have to know? So this is chloroform act as a detection agent of primary amines. This is also used in primary amines carbylamine reaction, that is known as, that is isocyanide form hota. So that's why that is also called carbylamine test. Okay, here it is written, is known as carbylamine test. In the test, chloroform is heated with a mixture of amines with the alcoholic NaOH, and it will give you isocyanide, the smell of isocyanide that is found. So that by that way we can say that this compound is whether primary or secondary or tertiary. Like primary and secondary we use, and both the aliphatic and aromatic amines give this test. Okay, this is the chloroform formula, you know. Now the triiodomethane. This is also again important thing. Triiodomethane IUPAC name is IUPAC name is triiodomethane, and the common name is iodoform. It is a pale yellow solid with the presence of distinct smell. Initially, the polyhalosine compound was used as an antiseptic. However, the antiseptic property of the compound was due to release of free iodine rather than the iodoform, which led to release in objectionable smell. Did you get that? What I am saying? This antiseptic property is due to the free iodine. Okay. Therefore, बाद में क्या होता है? This was releasing a gas which is like objectionable smell, अजीब सी smell होती है इसकी. So that's why nowadays other iodine containing formulations are in use rather than the iodoform. Okay, and iodoform, you know that CHI3, and you have done the test also, iodoform test, and the compound which is having CH3CO group, isn't it? The compound which is having CH3CO group directly or coming after the oxidation, that gives the iodoform test in presence of I2 and NaOH, isn't it? So that's why it was it can be used for the detection also. Okay, next is freons. It is very important compound. Freons, that is the collective term for the chlorofluorocarbon derivative of methane and ethane. These compounds are stable, non-corrosive and non-toxic in nature. These derivatives are usually liquefiable gases. Most common freon is freon 12. It is freon 11, freon 12, freon 13 and freon 14. और जिसको हम freon कहते हैं. तो the most common freon is freon 12, that is CCl2F2. Freon form tetrachloromethane by a reaction process known as Swartz reaction. पहले chlorination we will do, and we can do the halogen exchange. Two chlorine will be replaced by 2 fluorine. So that is Swartz reaction के according हम बना सकते हैं, and this is widely used in our refrigerator for refrigerator and for cooling as a cooling agent, this is used. Okay, so this is CFC is also we say chlorofluorocarbon. Yes. Now next is DDT. This is dichloromethane. It is used as, we know that it is used as insecticides. Yes, and the formula is used because sometime it can be asked that what is the like convert something to DDT. So that is important in this way. Preparation, we can prepare the this DDT by reaction of chlorobenzene, 2 moles of chlorobenzene when reacts with chloral. Chloral means CCl3CHO. Okay, so this is trichloroethanol को हम chloral कहते हैं. So when this two chlorobenzene reacts, this is the 2 para position hydrogen, isn't it? This and double bond oxygen reacts to form water. As a water it comes out, and there are the 2 bonds free now. So 1 bond with this, 1 bond with this attached. It should be CCl3, not CCl3 only. Okay, CCl3CH. Clear? So this is the structure of DDT. Dichlorodiphenyl, 2 dichlorodiphenyl, trichloroethane, C and C. Yes. Now the next is BHC or Gamexine or Linden 666. It is used as to form the explosive. RDX बनाने में इसका use किया जाता है, and that is how to prepare. This is when the benzene reacts with 3 moles of chlorine in presence of ultraviolet light and 500 Kelvin. Then it undergoes addition reaction and it gives benzene hexachloride. Although the benzene, it is not benzene, the double bond has removed, but it is still called as benzene hexachloride, BHC or Gamexine or Linden, used in RDX or to make the explosive. Yes. So that's it for the class, and we have finished with this chapter. So I hope you got the things and the important mechanism we have done, the important things we have done. Like what are the important things which is very much important with respect to the entrance also. So that also we have covered. Hope you got it, and so watch the video thoroughly and make the short notes for this for the future revision. We'll start with the next chapter, that is alcohol phenol ethers. So by the time, thank you class.